Hello, everybody. Welcome to a special episode of Geek Warning, brought to you by the Escape Collective. This is a special episode that is going to be open only to our members, at least in full anyway. So for anyone who's not a member, you'll get this for maybe about half the show or so. And unlike most of the other special episodes we've done, this is not going to be an Ask a Wrench episode. This is going to be one of our deep dive shows. And I am actually not in Boulder, Colorado at the moment. I just landed in Toronto, Canada about 2 hours ago, and I'm now in Hamilton, Ontario. I'm here with Jonathan Kennedy from Framework Bicycles. Hello, Jonathan.
Hey, James.
This is definitely one of the more unusual environments I've been in to record a podcast. So I just want to back up just a little bit. Framework Bicycles. So I feel like right now, I guess could we classify you as Instagram famous at the moment?
I don't know. What's the threshold? I feel like that's 10,000 followers.
Okay, so you're maybe not quite there. You're getting there. You're getting closer.
Thank you.
But anyway, this building that we're in at the moment, I am not in a building that says Framework Bicycles on it. It says Core Print Patterns on the front of this building.
Yeah.
So what is Core Print Patterns?
That is the machine shop, tool and die business and injection molding facility that we are in. So for the past 10 years or so, that's the business that I've done to pay the bills and keep myself busy. And it's grown substantially. Well, I wouldn't put it that way. We've added a lot of equipment over the years. It's still just Elise and I, and we run a modest business, but we started in like 800 square feet with a little woodworking kind of shop and a small CNC router, and built it up from there. So all the equipment that you see here has been added through cash flow and just growing the business over the past 10 years. So that kind of culminated throughout the pandemic with this injection molding machines that are right beside us right now, where we were doing injection molding work for the Ministry of Health, producing PCR testing consumables, so plastic components that the labs were using. And that was involved and tiring and kind of pushed us to our limits. And so once we got out of the other end of that unscathed, I took a little bit of time to work on some personal projects, and that's what led to the bikes.
Core Print Patterns, tool and die company. What sort of stuff were you doing here besides injection molding? So the injection molding thing was kind of something that popped up.
The most recent, yeah.
During COVID. What have you been doing before then?
So the trajectory from the very beginning was we started making foundry tooling. So that's the tool and die aspect of it. The kind of overarching terminology for that is pattern making. So pattern is what a foundry uses to produce the mold into which they make a metal casting. So you can have reusable or disposable molds or expendable. So a lot of the stuff we started doing in the early days was sand castings. So the mold is broken each time the metal is taken out of it, and the foundry uses a pattern and the broken down sand. They reclaim the sand, put new binding agents in it, and then pack it into the mold and take it out. So it's kind of like you kind of think of it like those little popsicle things where you got your kid put the juice in and you get the part out. So it's kind of like one step. You need our tool to make the mold that they put the metal into, and the mold gets used every time. So those type of products are often made out of wood, styrofoam, sometimes metal when you get into higher production stuff. So that's why we're able to start with sort of low barrier to entry compared to, a standard machine shop. Because the router only needed to cut foam, wood, and things like that. So that's where I started doing a lot of 3D surfacing and 3D modeling to get that work done. So from there, we grew into production machining, where most foundries have the requirement to do post-processing on the castings. So typically, they're not accurate enough for their final purpose, so they need to have machine features added to them. So we were looking at kind of adding other revenue streams to the business, because the thing about tool and die making is you only make one of something, and so you've got to constantly kind of be turning over work. And that's okay if your customers of foundries are busy and they have people always approaching them for new work. But if they're not that hungry for work, you don't see very much pattern making, because they might just make the parts they're already making, and that's good enough for them. So we kind of said, we've already got this client base of people who trust us to do complicated work. We can approach them for machining contracts. So that's where we started to add some of the more expensive metal cutting machines. And those also allowed us to diversify into more expensive tooling. in terms of the material that they're made of. So higher production stuff is often made out of more robust materials. And the quality of the tooling, if it does cost you more for a quality tool, it can be rationalized in that you're going to be depreciating that over a lot of parts, and you might have cost savings on those parts. So that's where we started to get into the, I would say, differentiating on quality more. If you're making 500,000 parts a year off of one pattern, and you can save some cleanup time on each of those castings because it's a high quality tool, the customer's willing to go for that. So that was a good thing for us. And then we got into die casting and other forms of casting, like investment casting. So that's where we make an injection mold for a wax part, and they use that at the foundry to make the mold. And then that became injection molding, was kind of the final stage of that. The medical components are pretty demanding. And that's when we added the injection molding machines to produce them.
Hence why we're sitting in this basically like big plastic curtain room right now.
Yeah, so Elise has her office set up in the clean room right now since we're not running those products anymore. But yeah,
it's pretty good for sound though.
It's good. Yeah, like I don't know if the mics can pick it up. Like the compressor kicks on every once in a while, or the heat. So yeah, it's nice in here, clean.
So I guess to summarize, essentially, you have spent several years now basically just making a bunch of different stuff using a bunch of different methods. Would that be safe to say?
Yeah, so I kind of didn't answer that question all that well, and that like what fields were we engaged in might have been something you're interested in. So we general engineering, I would say we did a little bit of aerospace, some medical, transportation. We did have our ITAR certification, which is military, but didn't actually end up doing any stuff like that. All the aerospace stuff we did was civilian. But yeah, like when you deal with foundries, you're dealing with any product that might go through their doors. So foundries don't necessarily specialize in a particular area of work. Like there are some of the aerospace foundries we worked with that's kind of all they do, just because they're such a premium product. But a lot of places, they more specialize in the alloy and the process. So if your end product demands that, you would approach them not because they operate in this arena, but because they make a particular type of component, like maybe small aluminum parts or big iron castings. So things like that.
So how did bicycles come into this whole thing? Because I think, needless to say, it's not really a super direct path from one to the other.
It is and it isn't. I think there's a lot of overlap between people who are working in trades and sort of a hobby that they work on. That could be like a car guy, people who are into tinkering and whatever it might be. So I've always ridden bicycles, and it's sort of a played out trope, if you will, of like the guy with the machine shop wants to make a product that is also his hobby, right? So golf putters, whatever it might be, right? So bikes was that for me. It was when we finished up the medical project, we were in the pandemic, things were opening up again, but there was still a lot of bicycle supply chain shortages. At the time I was riding a fixie, and that's like less common at the bike shops around here. So trying to source some components for it, it kind of began a little innocently where I just needed like a rear cog, on like Phil Wood's website said they were sold out or whatever it was. I thought like, hey,
you're looking
yeah, my
around,
back
like,
is to a CNC machine that can make this thing. Like, don't be lazy. Like the $50 from Phil Wood seemed a lot nicer than figuring out how to make the thing. So I guess that's probably the project that snowballed it all, was that. And then I thought like, okay, start looking at the bike. I'm not someone who has an intimate knowledge, like a bike mechanics kind of knowledge of how they go together, but I'm fairly capable of like undoing a bolt with an Allen key and seeing what happens next. So yeah, then it was make myself a frame after I looked at a couple different building techniques. I have very rudimentary welding skills, TIG and wire feed. So I actually had bought a bunch of chromoly tubing from McMaster Carr and thought like put it on the mill, figure out how to cope it and weld it together. And that kind of sat on the shelf for probably a year or more. The whole like super hands-on thing never really appealed to me because you have to be on every single time you're trying to do it. A little slip of the finger here and like you either got to backtrack a lot or there's some imperfection in the final part that will always be there and you'll know it's there. So yeah, the welded bike never really took off. And then, yeah, I don't know if what happened first, if I tried making the bike the way I did, and then someone sent me like Tom Sturdy or Bastian's work, something like that. But I thought it's pretty easy to cut a socket into an aluminum part and plug a carbon tube into it. So I ordered some carbon fiber tubing from McMaster-Carr this time and bought some aluminum blocks. And by the end of the week, I had a bike frame put together. Super basic because there's nothing on the frame other than two wheels. So yeah, I ordered a Ritchie fork, and then I had a bike that I was riding around. So went out to a couple group rides, and people started asking questions about it. Like, bike people are, for the most part, super supportive and enthusiastic and curious. And I think there's a lot of people in the bike world who want to know, like, want to have the knowledge and want other people to know they have the knowledge. So when you're riding something that they haven't seen before, I think they're by nature curious. And one, like, I've been with people who are like, okay, my buddy lives around the corner, we got to go see him, we got to show him this bike. I'm like, okay, that's probably what led me a little bit into trying to pursue it a bit more deeply. I think had I known that you can have that level of enthusiasm and it doesn't necessarily translate to revenue, I might have been a little bit less gung-ho.
What are you talking about? I flew here in my private jet. What are you talking about?
Yeah, G10s in the driveway. Yeah, I got a lot of positive feedback about it, and I thought, like, well, hey, you've kind of got a bit of free time on your hands right now. You've got all this equipment that you just paid off, and you're enthusiastic. Like, I've always wanted a product to make. We've only ever done other people's work. So yeah, I work for myself, but I still have masters, and still with making bikes, that's the case. But I think there's a very diversified consumer base compared to, like, we might have had 5 or 10 anchor customers with the core business, right? But if I sell a bike every couple of weeks, that's very different than being dependent on one person going under. And, like, we still are operating the other business. So partially it's a passion project, but also another diversified business stream. And I think I do have something to add to the space. I don't think it's just another guy trying to brand a bike. So yeah, then I look much more seriously at how do you make a bike with the skills that I have. And like, the big thing in machining and kind of general manufacturing in North America is about automation and streamlining, and not necessarily removing humans from the equation, but making sure that their contributions are maximized.
Can you talk a little bit about how your frames are made? Because, like I said early in the episode, that you're kind of Instagram famous. You've got a bunch of people following what you do on social media at the moment. But for someone listening to this podcast who is not familiar with what a framework frame is, like, what are we talking about?
Yeah, so a lot of people think it's a retro thing where I'm doing alloy lugs and carbon fiber tubing. So either the very first genre of carbon bikes, or more modern, it's most bikes made the similar way are using SLS or direct metal laser sintering for the lugs, and then they're bonding in carbon fiber tubes. So my distinction in that area is that we mill all the lugs out of billet 7075. So that's just a aerospace grade, high strength aluminum alloy. And yeah, so the whole thing is done in 3D modeling software first. The bikes are all fully parametric and custom at this point. The machining of the lugs is automated somewhat in the same manner that a 3D printer kind of looks after making the product. You send it the file and the slicer will do what it needs to do. But a lot of the work that went into setting up this kind of system for making bikes was in developing a robust CAD model for the bike. So that's a 3D model of the bike, and then making sure that workflow carries through into the CNC machining. So the actual programming of the machines is done automatically from inside the same software package. So I'm not like telling the machine what to do every time for a new bike. I just put in the appropriate piece of material for, say, a head tube, send over the instructions for a given rider's bike, and a couple hours later, I've got a head tube coming out of it.
And when you say parametric, what do you mean by that?
Parametric is like, let's say you've got an architectural drawing of your house, and you want to make your living room 10 feet longer. You just enter 10 feet into the living room dimension, and the house drawing will update to accommodate that. You're not starting over from scratch, redrawing your house with that living room. So, yeah, there are a set of parameters that define the 3D model. So that's the parametric aspect of it. Most of them are familiar to anybody who's looked at buying bikes and reads geometry tables. Like the main things that drive it are that kind of 2D sketch of the double diamond shape. But then we've got a whole host of other things that are some idiosyncratic to our process, but also just little things that the consumer might not think about, like tire clearance, the brake caliper or rotor diameter, the bearings we're going to use in the frame. Those are all part of it, the thicknesses of those. And then also the intersection points of where all the tubes come together on the lugs. So you wanted a bit more standover, but you wanted a horizontal top tube. I can kind of drop the whole top tube down on the head tube and it would stick out of like your stem stack would stick out a little bit above that. But all those things are built into a spreadsheet of variables basically. So for a new customer, we start by talking about, what style of bike do you want? And then go to fit data and then start to populate all those dimensions for the bike and then send an initial drawing. And they might say, that looks good. I would like a little bit more, whatever it might be. And we can tweak the drawing. Once it's all approved, then I basically just hit go on the machining of the lugs. So that all happens within about 30 hours of machine time. So there's 5 distinct parts, right? Your 2 dropouts, seat cluster, bottom bracket cluster, and head tube. So those are the 5 components that we machine. And then the tubes we produce using filament winding to make the carbon tubes. So those are also something we have quite a bit of control over.
Speaking about control, or I guess having control over things, I think the one thing that's always, I guess one thing that may be really interested in what you're doing is you're essentially doing nearly everything in-house, almost from start to finish, right? Like pretty much in this building that I'm looking at right here, right?
Yeah, the only thing we don't do currently is the lugs are all ceramic nickel coated, so it's an electroless nickel process. That's for a couple reasons. The main one being galvanic corrosion with the carbon tubes. Like carbon and aluminum are a mixture that you need to know how to handle. It's not like the bike's going to disintegrate, but it's like if you didn't paint your steel bike, it's going to rust, right? There are preventative measures you can take for certain forms of corrosion. So that's one of the steps we take. And yeah, that's a pretty specialized process. There's only like one place around us that does that particular product. So, once a week or once every 2 weeks, we send a batch of bikes and accessories and whatever other parts we might have on the go, and they plate it. Other than that, yeah, so I don't make aluminum here. I'm not smelting aluminum.
That's probably a good thing.
I don't make like pan precursor to make carbon fiber. So yeah, we buy raw carbon fiber and epoxy and we turn those into tubes. And we take the blocks of aluminum, we turn those into parts, get them plated, and then we paint the stuff in-house. And yeah, so we're not buying, it's not like we're buying tubing from someone and cutting it. We're not buying, Paragon Machine Works components and welding them onto the frame. So yeah, there is a high level of stuff we do here, but I don't know. There's a lot of kind of marketing and branding that goes around like done in house, and I don't really think that's people who are watching know that, and I don't need to remind you about it. I guess is my approach. I don't know why, but yeah, I don't brag about it, but I think part of it is wanting to maintain quality, but also wanting to maintain cost and trying to deliver the absolute best product I can. Like our bikes aren't cheap, but they're, I think, probably unrivaled value in terms of material qualities and construction.
You said early on that a lot of people have this idea that your frames are retro, and I think a lot of that probably has to do with sort of just the appearance of it, which is completely understandable. How are these not retro though?
Well, I think the everyone goes back to everyone's got their brand that they remember, whether it's like the early Giant stuff or a couple of the British brands like Allen, I think did some Vitus.
Yep.
Vitus, I don't know.
Right. Vitus, yep.
Yeah. So those were like I was born in 87, so some of those came before me, some came after, so you'll have to help me out a bit here. But I think the reputation with a lot of those was that by the time they were potentially having failures, the industry had already moved on from that construction methodology. My opinion on why that isn't because it's necessarily a faulty manufacturing process, but because they found a cheaper way to do mass-produced frames in terms of all carbon. So they didn't really know how to mold the lugs. Tubes they had a handle on early 90s, right? They were probably all roll wrapped. So I think some of the very early frames probably used cast lugs that would have otherwise been used in a brazing type application. Like they certainly weren't machined or 3D printed
They
back
definitely
then.
were not
So
machined or printed.
yeah,
Yeah.
so the part of the reason that they might have fallen apart is accuracy, and then the alloys that are used in casting are quite different.
A lot of those frames just fell apart because of the galvanic corrosion issue too. It
Yes.
wasn't really something that was on their radar, I think.
I don't know. I can't speak to that, what their engineers were aware of. I'm sure that that was like, I think the same thing happened in aerospace of like, you don't know a problem exists if you don't know it's there. So then once they learn about it, you put fiberglass in or insulating materials or use things with different galvanic potentials. So I think there were probably myriad reasons why they didn't perform that well. Accuracy, construction method, bonding agents weren't there, galvanic corrosion. So and they didn't care to really solve it 5 or 10 years later because they were already making bikes in a way that was probably cheaper. Not I don't mean that like the bikes were probably also better and cost less. If you can mold the entire thing, you're saving some steps.
Right. And there's no point in worrying about having to replace an older frame like that with the exact same frame if you can offer a customer under warranty a newer, more modern thing that they might be happier with.
Potentially, or they just phase it out altogether. Like I've had some people with, I think BMC has done it more recently with some of their time machine stuff where there was a lot of carbon, but also still some aluminum. And they've said to me, like, hey, could you help me? You're doing bikes this way. BMC basically just said, no, we won't even touch it. I don't know. I don't think that indicates that they don't think highly of it, but just that they've moved on and they
Sure.
don't like whoever their subcontractors were. Like it's just like they don't even have that capacity anymore. So yeah, and there's a ton of bike brands doing a similar construction methodology right now.
Okay.
And most carbon bikes have the same set of joints. They're just hidden under sanding and some paint. It's pretty rare to have a full monocoque chassis come out of a mold.
Yeah. And it's pretty unusual, particularly from a mainstream brand, to have a carbon fiber frame that's unpainted because most of the time, the reason why those frames are painted is because they want to hide the joints.
I think to a degree that like we can talk about paint. I'm sure we'll get into it later of why we don't offer a ton of colors, but there's a few reasons. Like I am of the opinion that a frame, if it looks raw carbon, should at least be clear coated for moisture and UV. Like those are the two things that kill carbon. Is UV will break down the matrix and moisture ingress will do the same. So automotive clear coats are engineered to do exactly that, to prevent both against UV and water. So I think there is a need to paint a carbon bike frame. There are brands who do it well and are kind of showing off how good they are at carbon by leaving it naked, if you will. Like everyone points like Time as being people who are quite good at making a carbon fiber bicycle. And they leave a lot of exposed areas. I think they're still clear coated or high gloss, whatever it might be. So yeah, like there are, but even a Time bicycle has a ton of joints in it. Like the rear triangle's all bonded together, the dropouts are bonded in. So they do the front triangle in one shot. Everything else is sub assemblies and glued together.
Gotcha. All right. So the frames that you're making, you said you have essentially 5 CNC machined 75 aluminum, I guess, nodes or joints or something. And then you're using bonded in carbon tubes. What sort of frames do you make at the moment? Like what styles of bikes do you have?
Yeah, we're in the road to gravel spectrum. No suspension
right
yet. Yeah. We could probably throw a suspension fork on one of our gravel bikes. It's all coming out of the same parametric model. Like we don't have a gravel model and a road model. It just really comes down to part of it is like where do you draw the line in the sand for what you call a road bike or gravel bike, right? Is it head tube angle? Is it, chainstay? So yeah, we're not doing any stuff where we've got like the gravel bike has a drop stay to get in your clearance. We can kind of get around that other ways. So yeah, it's like if you showed my bikes to a non-bike person, they'd say those are all the exact same bike. Right?
Well, that kind of leads into what I wanted to ask you because to the more casual observer, like you said, a lot of people think these are kind of retro bikes. And certainly to the more casual observer, they'd be like, okay, these are aluminum parts and carbon tubes. You kind of just glue them together. You're good to go. What would you say makes one of your frames different? Like I guess what lies beneath that surface that most people just see initially?
I think quality in both the materials and the execution of the manufacturing process. So I am not able to tell you that that makes the world's best bike. I can guarantee you that it's an extremely well-made bike, but I think there's a lot of subjectivity in where you take it from there. So the material selection on the carbon was a little bit of certainly a learning curve in that I had not made carbon fiber tubes before. We did have a little bit of experience in carbon fiber production, mostly resin transfer and compression molding tooling. So there's a lot that goes into making carbon parts well, and I think it's no secret that like there are some people who think the bike industry doesn't do carbon all that well. Now, coming from an aerospace background, the aerospace is not perfect either. So it's not like an industry problem. It's more just like probably, trying to make something at a price point. So there are trade-offs to be made in manufacturing. So for our bikes, I wanted carbon in the tubing because I really feel that that is the best product for the application in terms of the damping you can get out of it and the differential stiffness, like the anisotropic behavior you can get from it. In the joint areas, I'm much happier to use an alloy. First, because I can make those parts on a mill in a way that other people I don't think can. So some of the advantages of doing it that way that we haven't discussed yet are I basically put a raw block of aluminum in the machine and I'm taking out something that is needing no human intervention after that, other than perhaps some minor deburring and then offer plating. So 3D prints take, certainly direct metal 3D prints take a ton of work, right? You've got to get the support material off them. Then, a ton of hand finishing, and they're not very accurate. You can kind of think of them as like very accurate digital castings. It is a casting process in my mind, the solidification that goes on with them. And you are left with a surface that really looks like a sandcast product. So if you want a certain level of fit and finish, you're putting in hours of hand fettling at the, starting with little files and stuff and whatever abrasive media you want to use. So I didn't want people doing tasks like that in the production of the bikes. I wanted it to be let the machines handle the things that the machines are good at and let the humans do the things that the machines can't do. And in doing so, trying to remove or like move that labor cost elsewhere. That whatever, like if you look at most bike construction methodologies, they depend on having an army of people. If it's carbon layup, you hear brands brag about, I've got like 700 pieces of carbon, individual pieces that need to be laid in by hand. And from someone coming from a manufacturing background, I just look at that and think like, that's a nightmare. Like there's no chance that you get all of those perfect, right? The more steps you have, the more chance there is for something to go wrong.
Oh, hot take, because I'm here in Ontario, Canada, and the other company I'm going to go visit is Bridge Bike Works over in Toronto. And they definitely have a whole bunch of little pieces of carbon that are laid by hand. So
it's tough. It's tough to do that in Canada, anywhere in North America. Like you need talented labor. You can't just pick someone off the road and say, "Hey, come make this bike for me." So if your head layup guy leaves, you're in a bad position, I think. So
we'll stay tuned for that episode coming up, because I'm going to go head over there tomorrow. I mentioned earlier that I'm in this building. You and I are in this clean room setup here. Nearly every process that goes into a framework frame is done in-house here in this building, in these walls. But the other thing that's interesting about that is, as far as the fabrication of the frame goes, you're it. Like the person that I'm sitting across from right now is the person who is doing pretty much the entire thing from start to finish, right?
Yeah, currently that's absolutely the case. I'm not selling enough bikes to warrant hiring someone. The other thing is like it is somewhat hands off. Like my role in it currently is mostly logistical. I need to make sure the machines have what they need when they need it. So the workflow from when a customer approves their order is like get the CNC machine running, making the lugs. I start working on the tubes, and that's done on the filament winder. So again, like it would be classed as a form of automated fiber placement where I'm not I'm not laying up carbon to make the tubes. The machine is doing it with a CNC control super accurately. I just put the resin and the carbon in the machine, let it run the program, and then I transfer that into a mold and pressurize it, let it cure overnight. So part of the production of the tubes was wanting, again, to get rid of any of that sanding. Like you watch video footage of whoever it might be taking a carbon frame out of a mold. Like it's not done when it comes out of the mold for the most part. You've got to deflash it. Maybe you've got parting line pinch you got to clean up. You've got a ton of hand finishing to do just before you bonding your subassemblies. And then from there, you've got way more hand finishing and then paint. So yeah, you've got labor of assembling the carbon into a mold, and then that's true of a alloy frame as well, right? Like welding. Even if you go to places that are kind of batch manufacturing, you still have, even if your machines are all set up for cutting your tubing, notching, or whatever, you still have to cut all those tubes, probably deburr them, prep them for weld, get them in a fixture, tack them up, send them out to finish welding. Like that's all just human time along there, and there's no substituting. You can't not use skilled people if you want a good product in those processes. So I'm not saying I could have anybody walk in off the street and do what I'm doing, but it's a very scalable process in that um, it doesn't take a huge amount of training to load blocks of aluminum into the CNC machine and kind of make sure the machine's happy while it's running. Some of the more involved processes that we do are the bonding of the frame. And again, that's not, you don't need your 10,000 hours of weld training to be doing that, right? To make it perfect. It's like,
It sounds like essentially most of the work that you've put in, a lot of it's on the front end, just kind of getting all the systems set up and certainly the programming, that sort of thing. But then as far as the production goes, I mean, obviously you're leaving a lot of that up to the machines, but in terms of the human aspect that's required to go with that, I mean, would you say kind of it's mostly kind of related to like material handling at that point?
yeah, there's like one way to look at it might be what would my first hire be? Like who would I be hiring? And honestly, it would probably be someone to handle customer facing things in terms of sales. Like there's as much work in custom bikes just doing the back and forth as there is making the bike for me. It probably takes me under 10 hours to make a bike, my total time put into it. The machine time and kind of the waiting for each of those processes stretches that out to with plating and stuff and shipping. Could be 2 or 3 weeks to make a bike from when I start to when I finish. But my actual time spent on it is hours. So it might be 8 hours of communicating with a customer to make sure everything's perfect before we go ahead and make it. So yeah, I think that would be the first role. But that's another thing you can't automate, right? Put people in areas doing things where they're really adding the human benefit to it.
Oh, people are trying though. You just haven't found the right large language model yet, right?
Yeah. Chat GPT selling my bikes. That's what I need. Don't know what the geometry would look like on those. I do use Chat GPT a lot. I actually posted about that a bit when I was saying, like, could I do some geometry charts for a stock offering using Chat GPT to help kind of troll what a gravel bike looks like through the web? And I've used it more recently for a lot of like Arduino code on some of the machines we have to make the bikes. So yeah, it can be a good tool, but you got to know how to use it. So I don't
Right.
think it's ready to sell bikes.
Okay. Talk to me about precision, because I feel like that's definitely a very big theme of what you're doing here.
Yeah, I think precision has a lot of meanings depending on who you're talking to, but I would say control is maybe another thing, and not to be like, I'm not the guy that's got to be in control. It's about controlling as many of the processes as you can. Like manufacturing, that's all it's about, is just, do you have control over your environment, the equipment, how that equipment moves, how your materials are dealt with. So to make a good bike, you don't need to do all the things I'm doing, but doing it the way I do makes me feel confident that every single product that leaves here is sound to the best of my ability, and that I'm also delivering exceptional value in terms of the quality of materials that go into it and how they're executed. So yeah, a lot of the things we do that are unique to our bikes, like the bearings, the choice of headset, bearing assembly, and bottom bracket, those are kind of secondary to how we've chosen to do it. They kind of fall out of the process. If you were to say, I want you to machine in my welded bike proper press fit bearing, like a proper bearing assembly in the bottom bracket, you'd add a ton of cost to the bike. But like I'm already putting a lug in a CNC machine that's capable of, that order of magnitude of accuracy or greater. So it doesn't cost me anymore to add some really accurate, precise features to the bikes. And again, I'm not going to say that makes it you need to have my bike because the bearings will spin freely. But I can have the bike leave and say, I bet you're going to have better bearing performance than pick company X's super nice bearings, whatever they are, in a misaligned frame.
I mean, that is something that we deal with a lot in the bike industry, though. So just to back up just a little bit, when we talk about precision for you in terms of how things are machined, what level of precision are we talking about?
Probably most of your listeners are metric, right? So I'm going to say in microns, 5 to 10 micron might be a pretty, the press fit bearings we're going for. I'm thinking imperial, so I'm going for like 2/10. So I think that's 5 or 6 microns, if I've got my conversion correct. So yeah, like the machines we have are top notch. You don't necessarily need them to make a bike the way we're doing it, but we had them and it works. As sort of the give a baby a hammer and everything's a nail. Like part of the way I'm building a bike is using the skill set and resources that I have at my disposal and the things that I know I can do really well. I didn't want to have another welded bike where I'm differentiating on marketing. Like I really wanted the product to kind of stand on its own for how we go about making it and the things we care about and that isn't to say that there aren't a ton of other great bike manufacturers who care and put accurate work into it by any means. I just wanted to have it kind of foolproof in a way. Not that it is, like you can always find a way to screw stuff up, but if I'm having a bad day, the CNC machine doesn't care. It's still going to do a really good job. So yeah, we can maintain a really high quality of product, have control over costs, and hopefully run a profitable business making bikes, which is hard to do.
And just to clarify, when you say 2/10, you mean 2/10,000ths, right?
Yeah.
Okay.
0.0002 inches.
Right, because people who don't think in those sorts of manufacturing tolerances, I could certainly see someone being like 2/10 of an inch. That's huge. Like I can do that with a handrail.
It's sorry, my I think it's micron. It would be like a H7 fit or whatever you need for a bearing press fit on the actual race, right? So that's now I'm not machining the entire lug to that type of tolerance, but the features that need to have that. And then there's like, if you get into bearing fit, it's the size of the hole is a very small part of it. Like having a round hole is another part of it. Having those two holes be perfectly coaxial is probably the hardest part. You can make two really round things on either side of the frame, but it could be shaped like a banana if you look at it in terms of the axis that those go through. So yeah, there's a lot that goes into it. And, because we do that stuff for a living, make really high tolerance parts, it's kind of second nature and it doesn't, like we're not belaboring that. So I think it's an important aspect of what might differentiate our bike, but I'm not like saying like this is the best bike because we've got really nice bearing alignment in it.
Sure. No, I mean, I know that you've always been very careful to not characterize what you're doing as sort of like the absolute best.
There is no best bike.
Well, and I also feel like you're really careful to not even say that what you're producing is necessarily like better than something else. I guess to some extent, but as far as like what you were talking about a minute ago with like the bearing tolerance, bearing bore tolerances and stuff like that, and the concentricity and kind of where they sit in space and that sort of thing. That is definitely something that we do deal with a lot in the bike industry. I think most people listening to this podcast they've certainly had issues with press fit bottom bracket tolerances or
Definitely.
bearings that go bad prematurely, or a creaky headset, or like a bunch of like a big gap between a headset top cap and the frame, just stuff like that. Like it's people talk all the time about having these issues with bearings, but I feel like oftentimes when they say that they're having issues with bearings, what they're having an issue with really is the seats that those bearings are sitting in, right?
Yeah, it's like in engineering, you talk about like what's your frame of reference, right? So I think that's a huge reason that you have steer tube failures. I know you're the not internal guy, but I think that a lot of it actually has to do with if the two bearing seats in your frame, because those bearings are particularly bad at, they kind of will follow whatever path they want to because they're not quite acting like a spherical washer, but you have two chamfers that are not going to sit like a CNC spindle is going to hold a taper, right? They'll rock in there and they'll kind of, the principle is probably like elastic averaging. They're going to, like if your steer tube isn't perfectly straight, the inner races are going to kind of conform to that. If your head tube on your bike isn't perfectly straight, the outer races are going to kind of conform to that. And when you start to preload everything, you've got things that are fighting in opposite directions. Like I'm sure everyone that's tinkered with stuff knows like, oh, this was free spinning. And the second I tightened something down slightly, it all locked up. What happened? And that's just because when you didn't have it preloaded, there's a little bit of float, but those things weren't perfectly aligned to begin with. So once you tighten them up, they're going to lock up. So yeah, like examples like facing brake mounts, why can't I get my brake rotors to not rub somewhere? And probably something's not perpendicular to the axis of rotation. And like it's hard to make a mass produced frame and have all that stuff totally nailed unless you're going to do kind of a post-assembled cleanup on everything. So in a welded frame, everything's going to move when you weld. I don't care how good a welder you are, or if you're starting to integrate a lot of SLS prints into it, and you can kind of move the heat affected zone away from, say, like look at Tom Sturdy's bottom bracket cluster. When he welds that up, he's probably got way like orders of magnitude less distortion in the actual shell than someone who's got a weld the chain stays right to a sleeve of metal, right? So that's going to move a lot less, but it's still going to move. It's a saying in machining is like if you can't notice it, you don't have an accurate enough measuring tool. So I don't think bikes need that level of precision to work properly. But there's all the frustrations you're describing exist, but there's also not really an effective way for a consumer or your average bike shop to measure those things. So for me saying I can do that, it's like, what's it worth if no one's going to take my bike frame and put it in a CMM and like check everything, right? Like that's.
But I guess the thing is, again, like what I was talking about with, so many people having issues with various types of bearings on their frames.
Mm-hmm.
If you start with a correct foundation in terms of those bearings being exactly where they're supposed to be, then, essentially this is sort of like a tolerance stack up issue, right? Like you just start compounding these issues as you start putting more and more things on, as you start installing more parts. So, like you say, like you don't really make a huge deal out of the precision thing, but I mean, it is kind of a big deal, don't you think? Like it from a consumer standpoint, it's the idea that you very potentially could have fewer problems with some sort of spinning component further down the road because those bearings are where they're supposed to be to begin with.
I am 100% confident that is the right way to do it.
You do remember me saying at the beginning of this episode that only Escape Collective members were going to get the whole show, right? Well, sorry, but this is the end of the road for you today. That is, unless you head over to escapecollective.com/join and sign up. I've gone through the process myself. It is super quick. And in fact, if you head over there right now, I promise you can be back here in less than 5 minutes to hear the rest of what Jonathan had to say.